Another short presentation from the PLC University website. What is a PLC? This is the 22nd in the Factory Rat series, specifically discussing the comparison instructions. Consider our PLC database that we've been working with, specifically B30. B3 is an array of integers. What you see is one element of an array. This can be expanded out to 256 words in the B3 file, but we've only got one here. Specifically, let's look at one bit. B3, word 0, bit 0. And let's alias it with the text sequence start sequence, just to pick something out of the air. This statement, start sequence equals 1, is true or false. Put in PLC instruction form this true if 1, B30/0 aliased start sequence. It's also true or false. Consider another statement, start sequence equals 0, which is also true or false. And this is the instruction that is the equivalent, start sequence equals 0. It's true if off. So we have a true if on, true if off. Now let's consider N7, which is an array of integers. Just like B3 is an array of integers, we've expanded N7 to 3 words, 0 through 2, 0, 1, and 2, and we're going to use these in our demonstration. Here are some symbols that you recognize: equal, greater than, less than, greater than or equal to, less than or equal to, and not equal. Not equal is probably the one that you've maybe never used in an expression. All of these are true or false. So all of these are Boolean in nature. Remember, Boolean is true or false, whether you're talking about a Boolean data type or a Boolean expression. All of these expressions have a Boolean result, true or false, 1 or 0. In a computer, it would be expressed 1 for true, 0 for false. This is the equal instruction for a PLC. I have the value of 0 in all of these elements, but these are the instructions. N70 is equal to N71, true or false. Greater than N71, true or false. Less than N71, true or false. Greater than or equal to, true or false. Less than or equal to, true or false. Not equal. These are the 6 basic comparison instructions that you will find in PLCs. You can combine these instructions to give you a range of values that give you true or false. Both of these instructions can be true or false, and the result of both of them together ANDed, take the top one, N71 less than N72 and greater than N70. For these two instructions, the only values of integers where both of them are true and you get a true out from both these instructions would be when N71 equals 3, 4, 5, 6, 7, or 8. In the bottom set, because they are less than or equal to and greater than or equal to, they're going to include the integers at the extremes of the range. We've increased our true values to 2, 3, 4, 5, 6, 7, 8, and 9. This is how you might combine these instructions to have a true or false statement for a range of values. Here we have the same logic again, but we're comparing it to a limit test. A limit instruction is also a comparison instruction. These two rungs here are equivalent. In the top one, if N71 is less than or equal to 9 and greater than or equal to 2, that will yield a true out if N71 is equal to 2, 3, 4, 5, 6, 7, 8, or 9. Looking at the limit instruction, the low limit is 2 and the high limit is 9. And the test value 1, if it is 2, 3, 4, 5, 6, 7, 8, or 9, then that limit instruction, that limit test, will be true. I did it this way so you could compare the upper with the lower to fully understand how the limit instruction works. However, there's another way you can use the limit instruction. This one is inclusive. It includes all the values between N70 and N72, including 2 and 9. So it includes the extremes of the range and everything within the range between N70 and N72. The other method to use the limit instruction is to exclude the values between the two limits of the range. Look at the upper rung. What is less than or equal to 2? Well, 2 is equal. That would be true. 1 would be less than. That would be true. 0, -1, -2, etc. Or, because we have these in parallel, or greater than or equal to 9. What is greater than or equal to 9? Well, 9 is equal, 10 is greater, 11 is greater, and so forth. For a signed integer, N71, which can be anything from -32,768 all the way up to 32,767, both of these instructions, the upper pair and the lower limit, would be true if N71 equals anything between -32,768 all the way up to and including 2, or 9 and all the way up to a positive 32,767. The bottom instruction is a little bit more difficult to read because you're used to considering the range of values between the low limit and the high limit. But when you look at the value for N72, which is higher than the value for N70, the greater than and the less than now becomes exclusive of the range between the two values of 2 and 9. So this is a exclusive limit test and the previous was an inclusive. Those are the comparison instructions.